All right, Brandon Clayton, the Algebra Guy here. Today, as you see on your screen, our discussion will be over how to solve money word problems. So we got the cash on the screen, get you excited about making that money, but make sure you understand how to solve problems involving money. So let's pull up some problems here because these are problems that you'll typically see actually. Just working a lot of math and you coming up with dollars and change, and you'll see what I'm talking about. So let's solve coin word problems and ticket and stamp word problems. So you'll see these coming up. All right, so finding the total value for coins of the same type. So the way we're going to work our problems, you're going to see me bring up a table that looks like this as we think through how to solve problems. So we already know the value of quarters, dimes, nickels, and pennies, right? So this is how many I have times their value gives me the total value, and the total cost of all those that change, let's say in my pocket, was $6.64. So I'm going to use that model as I work through these problems, and I'm going to think through this system to help me make sure I covered it thoroughly. So let's get to it. Let me get my preferred colors out. There we go. All right, so Alberto has $2.25 in dimes and nickels in his pocket. He has 9 more nickels than dimes. How many of each type of coin does he have? So how do you solve a problem like this? First, we read the problem. Now we need to identify what we're looking for. We want to know how many of each type. So how many nickels, how many dimes, and how many nickels does he have? Let's go ahead and identify or name the variable that we are looking for. So let's see. He has 9 more nickels than dimes. Let's start out with defining what dimes are. So we're going to say the number of dimes will represent with a D, and we'll let N represent. It says they have 9 more nickels than dimes, so we're going to let the number of nickels be represented. Nickels be represented by dimes plus 9. So that makes sense, right? Because we got the number of dimes, and then you got the nickels is the number of dimes plus 9 more. So we can just use these two. We don't have to create a new variable. So what are we dealing with? We're dealing with dimes, and we're dealing with nickels. So let's think about an equation we can set up. So I got the identifying. I want to translate this into some kind of equation. So how many do I have? How many dimes do I have? So I have D number of dimes. I don't know how many that is, but I know dimes are worth 0.10. And if I multiply those two together, it's just going to be 0.10 times D. And if I had nickels, we said nickels are going to represent D plus 9. And nickels are worth 0.05. So what's the total value? Well, whatever the number is times what the value is. So like if we have 5 nickels, it'd be 5 times 5 cents, which is 25 cents. But we don't know the number. We're just going to say it's this number, whatever that is, times 0.05. So we can rewrite that. It looks like this, 0.05 times D plus 9. So this is supposed to be 0.05. So that's the value. Now I want the total value. All should add up to what? The total, when I add all this and this all together, it should give me $2.25. So what's the equation that I can write to come up with this? Well, I know that this value plus this value should equal that value. So that's what I'm going to write. There's going to be my equation. It says 0.0D, that's my value for dimes, plus my 0.05 D plus 9, that's my value for nickels, should all add up to 225. All right, so now we begin to solve it. So how do we find what the D equals? So we're just going to just try to simplify this. First, I see I can distribute this 0.5 to both of these terms here. So that's going to give me 0.05 D. And plus, looks like 0.05 times 9 is going to be 0.45 and that all equals 2.25. And bring this down as well. I want to double check my decimal, so I'm gonna pull out my calculator. So what do we got? 0.05, 0.05 times 9. Okay, good. Just want to double check that. Sometimes I'm like, okay, is that right? All right, so let's keep working this. We can simplify this a little bit. Combine our D, 0.10D and 0.05D would give me 0.15, basically 15 cents it looks like. 0.15D, I could go ahead and write this step out. 2.25. I could subtract 0.45 on both sides. And when I do that, that leaves me 0.5D equals, what is 2.25 minus 0.45? I'm not going to even bother, though I can. There's no 0.2. Let's just use our calculator. 2.25 minus 0.45 is 1.8. 1.8. Last step here, I need to divide by 0.15 to get my D variable by itself. These crossed out to just give me D. And now I can divide 1.8 divided by 0.15. That's not 0.15, 0.15. My goodness, 0.15. There we go, 12. Now I need to double check that since I did it that many times. So let me do that again. 1.8 divided by 0.15. All right, so 12. So D equals 12. So now I know how many dimes I have. I have 12 dimes. So we got 12. Put this in blue. So I have 12 dimes. How many nickels? Because it says of each type. How many nickels? Well, it says nickels are going to be the number of dimes plus 9 more. So 12 plus 9 gives me 21. There we go. And we're done. So let's check to see if we did it right. How could we check? Well, does this combination add up to 225? We could check. We're pretty sure 12 times 12 dimes is $1.20. How many nickels is that? 21 nickels. Let's see. So 21 times 0.05 is 105 plus $1.20. Yep, 225. Yay, we got it. Now let's make sure we answer it in the complete sentence. How many of each type? We have 12 dimes and 21 nickels. You don't want to just say 12 and finish, or 21. You want to say the whole thing, 12 dimes and 21 nickels. And don't get them confused and say 21 dimes and vice versa. All right, so fantastic. That's how we set up these problems. Now the next problem I want to encourage you to work. And the problem is as follows. Maria has $2.43 in quarters and pennies in her wallet. She has twice as many pennies as quarters. How many coins of each type does she have? So pause it here and see if you can work this and at least get it set up as far as you can. All right, so we're looking at, we read it. We're identifying what we're looking for. We need of each type, and those types are pennies and quarters. We need to name the variable. So we're going to name our pennies just P. And we're going to name our, she has twice as many pennies as quarters. Actually, I'm going to do quarters. And the reason I'm doing quarters is because it says there's twice as many pennies as quarters. So quarters is just, we're just starting off with quarters. But the pennies are going to use the quarters to multiply by. So so this is going to equal my number of quarters. And for pennies, number of pennies, it says twice as many. So 2 times that quarters as a quarter. So here we are with our, I'm just going to abbreviate for time's sake, just Q for quarters. How many we have? We have, I guess I'll write it out since it's going to be the same thing here. Number is going to be Q. We don't know how many. We're looking for that. What's the value? That's 0.25. What's the total? It's 0.25Q. Because the number of quarters times the value is a total value. How many dime or pennies are there? There's pennies. So how many pennies? Well, we're trying to figure that out, but we do know it's twice as many quarters, and each penny is worth 0.01. What's the total? Well, that's 2q times 0.01, so 0.01 times 2q. All right, so now we know that this is totaling up. When we add up all this right here, it's going to add up to 243. So now we've got we need to translate this into some equation we can write. And to do that, we can say, well, we know that 0.25q plus this adds up to 243. And that's what I'm going to do. So I'm going to go 0.25q plus 0.012q is equal to 243. And now I can start simplifying and solving this. So this is going to stay the same. If I distribute this 0.01 here times 2, that's just going to make that 0.02q equals 243. I can combine my q's. 25 cents plus 2 cents is going to give me 27 cents. Q. And that's equal to 243. And now I could divide by 27 cents on each side, or 0.27. And for that, of course, I'm going to take my calculator out and do 243 divided by 0.27. Oh, that's a beautiful number after all of that. So this is going to go to 1q, and it looks like q is equal to 9. Yay! So that means we have 9 quarters. So this is 9 quarters. So if we have 9 quarters, how many pennies do we have? Well, we have twice as many as our quarters, so there must be 18 pennies. All right, so we solved it. We can check our answer. And I'm going to let you check some of these, but I'll just mentally check this one again. So 9 quarters is how much? Well, 8 quarters is $2, so that must be $2.25. So this is our $2.25 here. For 9 quarters, how much is 18 pennies? Well, that's just 18 cents. So when I add these together, I should get 243. So let's add them together and see what we get. Moment of truth. 225 plus 18. 243. We checked our answer. Now, I tell you, a lot of students don't check their answer, and they end up making little mistakes and not catching them. But the excellent students who are wanting to do well and who consistently do well have some way of checking their answer. Did we answer the question? Yes. We want to write it out. There are 9 quarters and 18 pennies. So please, if you're doing an assignment, write that out so that the teacher has no chance to count yours wrong because you completely answered that question. Let's do another one, and I'm kind of gonna pick up the pace on this since we've done a couple, but please work this before I get to it. Then he has $2.14 worth of pennies and nickels in his piggy bank. The number of nickels is 2 more than 10 times the number of pennies. So we start off with pennies, and his nickels is some operation more than the pennies. So that's why I like to start off with pennies and say, well, pennies is just going to equal P, number of pennies. So we read our problem. We identified what we're looking for. We need both pennies and nickels. But I'm going to let nickels equal. Actually, I wrote that backwards. I want nickels right here. I want the number of nickels to be equal to the number of nickels is 2 more, so 2 more than 10 times the number of pennies. So 10 times these pennies. So that's what we want here. Now, we don't have to keep using this chart. So I'm just going to think through this now that we've done a couple. So we know that this number of nickels, and this number of pennies, as adds up at a total of 214. So now we can get to our equation writing, and we can say that we know that 10p plus 2 plus p equal $2.14. Why is that making sense? Because we know that this is our pennies, this is our nickels, and when you add them all up, it equals 214. Now we don't know what p equals, but we know that this equation should be set up like this. So now we're in a position to start solving. So we're right here at the solving part. I see that I can combine 10p with 1p to give me 11p. And I can subtract 2 on both sides. Now I got 11p equals 0.14. Oh, that doesn't look right, does it? Is it because I skipped a step? Yeah, that's what it was. Man, so I'm glad I did that. So I'm trying to skip a step, and now I'm messing it up. So the step that I forgot is to multiply by its value, right? So before I was going pennies and represented by p, and then I was putting a value right here. And I was saying this equals 0.01p. And I didn't do that. That's what messed me up. So then I got nickels, and that equals 10p plus 2, and the value of a nickel is 0.05. So the value here is this times here, the number of nickels times its value. So that'll be 0.05 times 10p plus 2. All this adds up to 214. So that's what I should have put in there. So I'm going to rewrite this 0.01p plus 0.05 times 10p plus 2. All right, so that's what we're trying to solve. Going to rewrite this in order to solve. I'm going to distribute this here. 10 times 0.05 is going to be 0.50p. And 0.05 plus 2 is going to be $2.05. And that all should equal 214. All right, can I combine anything? I could combine my p's here. 50 cents plus 51 cents is 50 cents plus 1 cent is 51 cents. And then I can subtract 205, leaving me with 0.15p or 0.51p. 0.51p is equal to 4. Why am I adding that up? Erase. I just subtracted $2.14, which left me with $2.05, which left me with should leave me with what, 9 cents? Is that right? So when I subtract the 205 from here, I only have 9 cents left. Yeah, that looks right. So now I'm going to divide by 51 cents or 0.51. It looks kind of strange now, but we're going to work it out. 0.51 divided by 0.09 divided by 0.51 equals, ooh, that's something's not right with that. So let me go back and see where my error is. 50, I got $2. Oh, what is this right here? I got to go back and erase this. Yeah, and you probably caught it. But right here, when I distribute it, 0.05 times 2, I added 2 plus 0.05 instead of what I should have done, which is multiplication. So I got to go back and erase all of that. And I'm actually going to keep this in the recording. because a lot of students struggle with finding their mistake and knowing what to do. And we just have to get good at that, because the teacher won't always be around, especially if you're taking a test. But you got to go back and look at each step and say, did I do each one right? And there it is. And yes, I make mistakes, and I'm not going to edit it to show that everything I'm doing is perfect. So I make those mistakes too. So this actually should be 0.1 equals 214. All right, now I'm continue 0.51 p plus 0.1 equals 214. And subtract 0.1. Subtract 0.1. That leaves me 0.1. 0.51p equals 214 minus 10 cents is 2.04. And let's hope this comes out better. So I'm going to divide both sides now by 51 cents. And let's see. So we got 2.04 divided by 51. 2.04 divided by 0.51. There it is. It was worth the wait. So P equals 4. So now this makes it so nice and beautiful. And you wanted to get an integer, right? Or a whole number, I should say, because I don't want a negative value. Because you know that you have whole pennies. I don't want to get a decimal. There's no such thing as 4.3 pennies. So I'm glad to get a real number there. So I'm feeling good about that. So I know I have 4 pennies. Well, if I have 4 pennies, how many nickels must I have? Well, if P equals 4, that means I'm just going to put 4 in there for P. 10 times 4 plus 2. So 10 times 4 is 40, plus 2 is 42. So that means I have 42 nickels. So those are my answers: 4 pennies and 42 nickels. We can check their answer by multiplying, and I'm going to check it since I messed up somewhere. And I want to make sure this is right. So how much is 42 nickels? 42 times 0.05 is $2.10. Well, if I added 4 pennies to that makes it 214. So yes, we did it correctly, and we answered the question completely. All right, I want to finish off with a stamp problem. There's a couple more I have, but for time's sake, I'm just going to close it up here with the stamp problem. But it's worked the same way. So let's see how to set it up. At a school concert, the total value of tickets sold was $15.06. The student tickets sold for $6 each, and adult tickets were $9 each. The number of adult tickets sold was 5 less than 3 times the number of student tickets. How many student tickets were sold and how many adult tickets? So we read it. I understand what they're saying. I need to identify what we're looking for. We're talking about the number of adult tickets and the number of student tickets. And let's go ahead and set up some variables to represent each. So I'm going to let S represent the number of student tickets. Student tickets. And we're going to let the number of adult tickets. See, I almost said A, but I don't want 2 different variables since adult tickets is some concoction of the number of students tickets. So student tickets sold for $6 each. Adult tickets, the number of adult tickets sold was 5 less. So it's 5 less than 3 times the number of students. Then 3 times the number of students. So there it is. So for my type, I have student tickets. And the number is S. The value is, what did they say the value was for a student ticket? $6. So the total value should be 6S. And for an adult ticket, we said the number was 3S minus 5, and those tickets cost $9. So the total value is 9 times 3S minus 5. So how much does this totally cost? Well, $1,506. So if I'm writing an equation to figure out this, I'm going to do it just like I did the other problems. And I'm going to say 6S right here plus this 3s minus 5 is going to be equal to 1506. Going ahead and solving this, I'm going to distribute here. First, I'm going to bring this down, 6s. This is going to be 27s, and minus 45 equals 1506. And we're going to combine our s's, 27 and 6, because they're like terms. What is that going to give me? 33s minus 44 equals 1506. And I'm going to add 44 to get one step closer to getting my s by itself. And when I add 44 to this, I get 33s over here equals 1550. Make sure that's right. Yeah, that looks good. So 1550. Now I divide by 33. And of course, I'm not going to do that by hand. I'm just going to pull out my calculator and do that. So we have 1550 divided by 33. Oh no, a decimal again, which means I did something wrong. So let's find it. Let's go back to, got this set up right, got that set up right, 5 less. So you see, notice I start from the beginning. I'm just going to kind of peruse through everything. So I started here, 9 times 3 is 27, that's negative 45. So yep, that looks good. That looks good, yeah. So I got my s's, I put those together. 27 and 6 is 33. Oh, man. Small mistakes, these little things. I put 44 instead of 45. All right, so that made a big difference. There's a little mistakes, and these just happen again. So I'm just going to keep those in there in our video to show these things do happen. So now when I rework this, it should be 33s. And it should be 45 there. So now it's, instead of 1550, it should be 1551. Let's see if that helps us out in our calculations. 1551 divided by 33, and there it is. So don't be upset if you don't get it right the first time. You get something kind of funky. Just know that there's a way to go back and check. And that's why we have a system that we step by step going through to check. And how do we know it was off? Because we know we're not going to have a decimal number for the number of tickets. You can't have 4.32 tickets. You can't have it, like, it has to be a whole number. So that's the thing that says, hold on, this doesn't make sense. A student who was just working the math and just trying to get an answer would have stopped there and said, okay, just write that number down. But no, that doesn't make sense. So these two steps right here are saying, does it make sense? Before we put that answer in. So we got how many student tickets? 47. That means if we have 47 student tickets, we have how many adult tickets? So let me put that in different colors. So we have 47 student tickets. Well, in order to find out adults, I just put 47 in place of S. So that gives me, I'm gonna write it over here, 47 minus 5, 3 times 47. 47 equals that, minus 5, and I get 136. So my adult tickets is 136. Voila. Now I could replace these numbers and see if it gives me the total of 1506, but I'm going to let you do that if you want to check it. But that's how you want to set it up. So as you see in our examples, the word problems for money is the same as tickets or stamps. So you don't have to worry about that. So we covered both of those. Thank you guys for tuning in. I know it's a bit longer, but I hope you found it helpful. I'll see you next lesson.